Alright, so in this video, I'm going to solve the equation 1 to the power of x is equal to 2. So, before we even start solving this, if, let's say, x is equal to 1, then I have 1 to the power of 1, which is equal to 1. And if x is equal to 2, then I have 1 to the power of 2, which is also equal to 1. And you can go even 1 to the power of 10 is still equal to 1. So you may be thinking, what possible value of x can make 1 to the power of x equal to 2? So let's try solving this. What I'm first going to do is start by taking ln of both sides. So I get ln of 1 to the power of x is equal to ln of 2. And ln is the same thing as the natural log. And the reason I took the ln on both sides is because it comes with a property that states that if I have something in the form ln a to the power of b, I can move this exponent b to the front, so this turns into b times ln a. So in this case, I have ln 1 to the power of x, and I can move x to the front. So I get x times ln 1 is equal to ln 2. And you may be thinking, we could just divide both sides by ln 1, and x would equal ln 2 over ln 1. However, the only problem with this is that ln 1 is equal to 0. And remember, anything divided by 0 is undefined, so this would be undefined. So we know that this equation has no real solution, but it could still have imaginary solutions. So to actually solve this, I'm going to use something known as Euler's formula. And basically what this formula is if I have something in the form e to the power of I times theta, this is equal to cosine of theta plus I times sine of theta. And I know to many of you watching this video, this may just sound like a bunch of gibberish, but just hang on. So let's say that theta is equal to 0, right? Say that theta equals 0. So now I get e to the power of I times 0 is equal to cosine of 0 plus I times sine of 0. Cosine of 0 is 1 and sine of 0 is 0. So I get this all is equal to 1. Now, what if we say theta is equal to 2k pi? And k is just a substitution for all real numbers. So now I get e to the power of I times 2k pi is equal to 1. Because all we did was we just substituted theta in for 2k pi into this same thing. So now, because this is equal to 1, we can remember our first equation, which we started with 1 to the power of x equals 2, we can substitute in this for 1, meaning I get e to the power of I times 2k pi to the power of x is equal to 2. So just think of this as 1. So I have basically 1 to the power of x equals 2. And now, with this, I'm going to take the ln, or natural log, on both sides. So I have ln e to the power of I times 2k pi to the power of x is equal to 2. So I'm going to now bring this x down using property of natural logarithms. So I get x times ln e to the power of I times 2k pi is equal to 2. is equal to ln of 2, because if you take ln on one side, you have to do the other side. And now I can also move I times 2k pi to the front. So I have I times 2k pi times x times ln e is equal to ln 2. ln e is simply equal to 1. So I get x is equal to ln 2 over I times 2k pi. And now I'm going to multiply this by I over I. So I get x is equal to negative I times ln 2 over 2k pi, because I squared is negative 1. So this is my solution. Alright, so in this video, I'm going to solve the problem 15 to the power of 50 over 3 to the power of 25. So to solve this, I'm going to first start by rewriting this as 15 to the power of 25 plus 25. So I rewrote 50 as 25 plus 25 over 3 to the power of 25. And the reason I did this is because now I can use the property a to the power of m plus n is equal to a to the power of m times a to the power of n. So in this case, 15 to the power of 25 plus 25 is going to equal 15 to the power of 25 times 15 to the power of 25. And I have this over 3 to the power of 25. And now this is equal to 15 to the power of 25 times 15 to the power of 25 over 3 to the power of 25, which is equal to 15 to the power of 25 times 15 over 3 to the power of 25. And this is equal to 15 to the power of 25 times 5 to the power of 25. Now another property of exponents is that if I have something in the form a to the power of m times b to the power of m, this is equal to a times b to the power of m. So this is going to equal 15 times 5 to the power of 25, which is equal to 75 to the power of 25. So this is my answer. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 10 to the power of 3 minus x equals 1. So whenever we're solving exponential equations similar to this one, we always want to make sure that our bases here, in this case 10 and 1, we want to make them the same. Because let's just say I have a to the power of x, and this is equal to a to the power of y. Well, we know that these two terms are equal to each other or the same, and we can see that both of them have a base of a. Well, in this case, doesn't that mean that their exponents are the same as well? Because if they're different, then that means this would be wrong. They can't be different because their base is already the same, meaning their exponents have to be the same as well. So in this case, if we were to change the bases so that they're the same, then we would know that the exponents are the same as well, so we could just set the exponents equal to each other and solve for x. So we want to make the bases of 10 and 1 equal each other. Well, that means that we have to change one of the bases. And we can't really change 10 to be equal to 1, so why don't we change 1? Well, 10 to the power of what equals 1? 0, right? Because anything to the power of 0 actually equals 1. So we should change 1 to 10 to the power of 0. And this still equals 10 to the power of 3 minus x. Now notice how these two bases are the same, just like this one. And think of 3 minus x as x, and the 0 as y. Because these two bases are the same, then that means that these two exponents are the same as well. So we can just ignore the bases for now and just set 3 minus x equal to 0. And now, as you can see, we've created a simple equation using our method. So now, to get the value of x, we're going to have to make it go to the right side. So we're going to add x on both sides. And these two cancel out. So we're left with 3 equals 0 plus x is x. So now we have our value for x. Now, why don't we go ahead and plug it in to our equation? So this gives us 10 to the power of 3 minus 3 equals x. So 3 equals 1. 10 to the power of 3 minus 3 is 0 equals 1. And remember, anything to the power of 0 equals 1. So 10 to the power of 0 equals 1. So we have 1 equals 1. And this is right, meaning our answer of x equals 3 is right.